Smart Cerebrum Private Limited is a team of academicians and experts who are into education field since decades. We are proud to be associated with more than 1,500 institutions across the country. We are into academic consultation, teacher training, student training, communicative English, Vedic mathematics, subject specific training, content development, and many more. Smart Learning is a service oriented social initiative from Smart Cerebrum Private Limited, wherein subject specific experts will be conducting online sessions for the student community at large. Please subscribe to our YouTube channel for constant updates about upcoming sessions and topics. All the sessions will be related to the syllabus and curriculum.
We welcome Dr. Balaji Rao sir and all our viewers for today's session. As this session is for grade 9 chemistry matter in our surroundings part 3. Dear viewers, please type the queries on our YouTube channel. We will be taking up the queries before the session ends. A very warm welcome to you sir.
Very good afternoon. Good afternoon to all the viewers. Friends, we will restart from where we had left. Last class, I remember we had started with the concept of solutions. That is, we had started with the concept about purity of substances around us, where I had mentioned to you that when we say there's a pure substance, that substance should be made up of only one kind of particles. So when we say it is, for example, we see some advertisements on cartons of food stuff saying pure. So when you say pure, supposing we say pure honey should be made up of only honey. That means the entire contents of the bottle should be having only particles of honey. Supposing to add to the taste, if some sugar is added, sugar syrup is added, then although they claim this to be a pure honey, it is not pure. So purity in terms of a chemist would be when a substance has all particles in it of the same type. That is, of all the particles should be of the same type, say chemical nature, only then we call that as a pure substance. Then we talked about mixtures and we talked about different types of mixtures. We talked about solutions in particular. Now we will take a few simple examples. We take copper sulfate and put this into water and shake this. And we keep it to stand aside. We take a test tube of water, add a few drops of ink into that, or gum arabic, or the glue that you use to paste paper. Shake that and keep it aside. And take some chalk powder, put it into a test tube containing water, shake this thoroughly, it becomes a turbid solution, a turbid mixture, and then allow this to stand for some time. After a while, when you see the test tube containing the chalk powder would have settled down and a thick solid will be at the bottom of the test tube. Whereas in the case of copper sulfate solution, copper sulfate plus water, the whole solution will be homogeneous. Homogeneous in terms of the entire constitution of the liquid will be uniform. Whereas in the case of ink, if you try to shine a beam of light through this, you can actually see the beam of light being scattered. So we are going to broadly classify these into solutions, a true solutions, a colloid, and a suspension. So let us see what these three words mean to us. We write the first one, a solution or a true solution. I'm told that I was blocking my viewer's view. So I'll stand here and write. I hope you can now see true solutions. These are solutions in which particle size is less than 1 nanometer. 1 nanometer is about 10 to the power of minus 9 meter, or it is 1 into 10 to the power of minus 10 centimeter. So a true solution is one in which the particles are extremely small, so small that they are less than 1 nanometer in size. Right. Then we come to what is called a suspension. I presume that you are making a note of this, and if you're not, I'll give you a minute or two to think over, to write, because these values do matter a little to us. Please remember, these values are of crucial importance to us. Now we come to a suspension. Sometimes we call this as a precipitate. A precipitate is a solution, or a true suspension is a solution in which a particle size is greater than 100 nanometers. 100 nanometers, so the particle size is so big that it does not fit into the space between water molecules, therefore the particles come out. Then we come to the point that we have raised just now, that is a colloid. A colloid. A colloidal solution is one in which the particle size is between 1 and 100 nanometers. So when the particle size is between 1 and 100 nanometers, we call this system as a colloidal solution. Now, how do we distinguish these physically? Physically, when we try to pass a suspension through a filter paper, that is, you can try this also at home. You can just take a filter paper, make a cone out of this, put this into a funnel, and the chalk powder suspension that we had made, stir it thoroughly, and then try to filter. You can see that at the bottom, you get a clear solution, the filtrate as you call it, and on the filter paper, you have the so-called precipitate. In fact, the best example for this is one advertisement that is coming up on the television quite frequently. It talks about a young child, a girl child, who in the morning, when the father is about to have his morning cup of tea, stops him from drinking, asks him to brush, and then she gives you a demonstration of a suspension being filtered. If you have looked at it, probably you can appreciate what I'm talking about now. So in a colloidal solution, the particles can simply pass through a filter paper. In the case of a true solution, the particles can also go through a filter paper, but there is a small difference. In the case of a true solution, particles of a true solution pass through a semi-permeable membrane. This is when it is a true solution. But when it is a colloidal solution, particles of a colloidal solution do not pass through a semi-permeable membrane. SPM. You might ask me, how do we know this? Now you said that, if you will ask me, sir, you said that particles of a colloid do not pass through a semi-permeable membrane, whereas particles of a true solution pass through a semi-permeable membrane. I'll give you a simple answer to this. Our body has, 5 sensory organs. All right. We have eyes, we have nose, we have ears, we have skin, and so on and so forth. Now, which is the largest sensory organ that we have? Obviously, it is the skin. Now, whether you want it or not, whether you like it or not, we constantly are sweating. Okay, during winters, maybe the amount of sweating will be less, but during summers or during physical activity, we profusely sweat. And when we sweat, we get a salt solution coming out of the skin. Now, the salt solution is a part of our own, digestive and excretory system, and whatever excess salt is there is coming out in the form of a solution. So the salt solution is coming out of the skin. Skin is a wonderful semi-permeable membrane example. But we have a colloid inside us. We have the blood. Human blood is a colloidal solution. We know that blood doesn't come out of the pores of the skin that easily. Just unless you cut it, it won't come out. So here is an example where, in the case of a colloidal solution, the particles can pass through a filter paper, definitely, but they do not pass through a semi-permeable membrane. So this is the basic difference between a colloidal solution and a true solution. A true solution, particles can pass through a semi-permeable membrane. In the case of a colloidal solution, particles do not pass through semi-permeable membrane. Please remember, this is a very, very, very important distinction between the two. This distinction becomes very important to us. In fact, as we go to higher grades, grade 11, etc., you will be learning a little more about this, where in detail we talk about all this stuff. Now, a solution essentially is made up of 2 components. One is called a solute, the other is called a solvent. So let me see what we do here. A solution, a true solution, if you look at it. A solution is made up of solute and a solvent. What is a solute? Solute is something that dissolves. This dissolves in the solvent. Okay, we'll put it like this. Solute dissolves in a solvent. Solvent dissolves the solute. How do we mean by, or what do we mean by this statement? If I take, for example, sugar, put this into water. Let us say I take 2 grams sugar, put this into 100 ml water. I get a solution of sugar. Here, sugar is my solute and water is my solvent. So when we talk about a solution, any solution will have two components, as we said. One is the solute, the other is a solvent. And the solute is always in smaller proportions, smaller quantities, and a solvent is always, by default, in larger quantities. Now, having seen this, we can have different types of solutions, which we have, I suppose, mentioned sometime in the passing. We have solutions of a solid in a liquid. Yes, what we have seen here. A liquid in a liquid, for example, milk, it's a solution, a colloidal solution, or honey in water, definitely, and a gas in water, gas in a liquid, or a gas in a gas. A gas in a gas is what we breathe. We breathe air, and this air we know consists of oxygen and nitrogen principally, and of course, in addition, a lot of other gases like carbon dioxide, carbon monoxide, and the polluting gases like oxides of sulfur, oxides of nitrogen, and in very, very, very trace quantities, less than about 0.005%, you have the so-called rare gases or noble gases or inert gases. So essentially, air is also a mixture, and seawater is a mixture. Then the water that you buy nowadays, yes, in fact, I don't have the label for this bottle yesterday. I bought this bottle somewhere on the drive, and there was a label attached to it. Somebody has pulled it out, and it says water, packaged drinking water with added minerals. So they have added certain quantities of calcium and magnesium into this in the form of their soluble chlorides, and they're supposed to have fortified this water. So now you call it as a mineral water. So these are all examples of solutions that we have seen. Now then, when we look at a solution of a solid and a solid, can it happen? Yes, we have already talked about this once. Solid solutions are otherwise called alloys. So we have what are called alloys. Alloys are solid solutions, especially of metals. Alloys are solid solutions of metals. The normally given examples for solid solutions are ornamental gold. We call this as 22 karat gold. We have brass, we have bronze, and so on and so forth. You have bell metal, you have, there's one more variety of metal called a silver. What is that called? Ever silver or something like that. They used to come out with one name for that. And we also have white metal. This is a very commonly used metal for small idols and whatnot. So what are alloys? Alloys are solid solutions of metals, for example, ornamental gold, and so on and so forth. But there's one more special variety of an alloy, which normally we do not come across. It is called an amalgam. I introduce one more word to you here. It is called amalgam. Amalgam is a alloy of any metal with mercury. So an alloy of any metal with mercury is called an amalgam, and amalgam is also a solid solution. So amongst solid solutions, we have the typical solid solutions like as mentioned, gold, ornamental gold, or brasses, bronzes, and you have stainless steel, for example. Stainless steel is there. All these are alloys, and these alloys are, as we see, solid solutions. And one special variety of the solid solutions would be an amalgam. An amalgam, as you can see, is always a solution of any metal with mercury. So whenever you see mercury in a alloy, you always call it as an amalgam. You have gold amalgam, silver amalgam, sodium amalgam. You can have any variety of amalgams possible. Fine. Then we come to how to measure the strength of a solution. That is, how do you know that a solution has more solute or a more amount of solvent? We'll take a commonplace example. I don't know how many of you people drink a coffee or tea. I don't think too many of you, because all parents are very careful about their children's health, and they promote children to drink. They ask children to drink the so-called, what do you call them, health drinks. I'm a Complan boy, I'm a Complan girl, I drink this, I drink that, and I'm taller, sharper, stronger, whatever that goes with it. So very few parents would advocate the use of coffee or tea. Okay, in case you belong to that family where you're allowed to drink coffee or tea, you know that coffee can be of two different types. One is the so-called light coffee, the other is so-called strong coffee, or in fact tea also. Now where if you have more decoction, less of milk and less of sugar, it is called a strong tea or a strong coffee. And if it is other way around, if you have less of decoction, more of milk, and maybe a little excess of sugar, or if you don't like too much of sugar, more of milk for that matter, then you call it as a light tea or a light coffee or whatever it is. Now, what we are seeing here is we're talking about concentration of a solution in terms of the solute and the solvent. So we now classify solutions into a solution where we have a dilute solution and a concentrated solution. A dilute solution is one in which amount of solute is less, amount of solvent is more. Or I can say, all right, the amount of solute is very less. I just put that much because solvent, let's not bother about it. If you talk about a dilute solution, the amount of solute is very less. In the case of a concentrated solution, the amount of solute is more. This is a very self-explanatory kind of a situation where even without any explanation, you can understand. You can say that when you take, let us say, 1 spoon of sugar and dissolve it in about a big tumbler, 200 ml of water, then you try adding more and more amount of sugar, the taste of the solution becomes more and more sweet. So we talk about a concentrated solution or a stronger solution in terms of a solution in which the quantity of solute is more. In the case of a digestive, you can have less amount of concentrated solution. I'm extremely sorry. I was disturbed by something coming on my screen. It just distracted me for a moment. All right, we come back to this. The dilute solution is one in which there is less amount of solute, and in the case of a concentrated solution, the amount of solute is more, much more. Right. Then we think about one more situation. How can we alter the concentration of a solution? This we have already seen. I suppose we mentioned about this last time also, but anyway, even if it is a redundant statement, it makes sense because ultimately the goal is that we should understand the concept in completeness. Now, if I take a tumbler of water, maybe say, as I said, about 200 ml of water, keep on adding sugar and keep on stirring it. At some point, the sugar refuses to dissolve. It says, no, sorry, I'm through, no more. The solution solvent says, sorry, I can't take any more. Then you coax it. You coax it to dissolve a little more of this sugar. How do you do that? One is by stirring. Then again, at a point, it says, sorry, no more. Then you heat it. When you heat it, as the temperature increases, you see that you can dissolve more and more amount of solute. So when a solution is heated, it can take in more amount of solute. That is what we are talking about, a solution in terms of saturating it. So at a given temperature, the amount of solute, whatever the quantity of solute has dissolved to the maximum extent, it gives me or gives rise to what is called a saturated solution. So here I use one more term, a saturated solution. A saturated solution is one in which the solution cannot dissolve any more solute at a given temperature. So at a given temperature, when the solution or when the solvent cannot take any more solute, then you call that as a saturated solution. Oh, I'm sorry. We seem to have lost somebody's connection. Yeah. Okay, I think we are back. Yes, I suppose we are back on line. Navya, are we back online?
Yes, sir.
Yeah,
It is
yeah,
coming
yeah.
now.
Thank you.
Yes,
There was
yes.
a small disruption in between.
Yes, sir. Internet issue was there, sir.
Okay, internet issue, fine. Because I was thinking that it was from my end, both my connections are working full speed. So that should be a small problem with the internet over there. Well, we cannot do anything about these small glitches because these are things which are beyond our control. All right. So we'll have to learn to live with these small realities. All right. Now then, saturated solution is a solution that cannot dissolve any more solute at a given temperature. But then, how do we express these concentrations? So, to talk about concentration of a solution. So, we can say concentration of a solution is equal to amount of solute divided by amount of solvent, or you can also write amount of solute divided by amount of solution. amount of solute divided by amount of solution, or amount of solute by amount of a mass of solute. Instead of amount, let us make it more specific. We'll write it as mass of solute. And here also, we will make the same rectification. So here we write mass, and here again mass. But then we need to quantify this, right? We need to quantify. We just can't take a ratio. We always talk about percentage. So percentage concentration of a solution is multiplied by 100. Fine. The question now comes back to me. Right, sir, how do we express these concentrations? Mass of solute by mass of solvent. You can also have one more. This is mass to mass. And you can have, for a solution, you can have volume of a solution also. This is one more statement you can look at. Mass of solution or volume of solution. For example, I have something to show you. You can have a look at this. It is given to my granddaughter for some vitamin D, the supplement. There should be, most of us incidentally or right now going through this stage of deficiency of vitamin D, I am told. Although we are apparently quite fine, because we are not getting exposed to light sunlight, especially young children like you, because now of course the schools have reopened to an extent, but before that, during this so-called pandemic period, most of the time you are forced to spend at home. So the lack of sunlight has caused great demand of for vitamin D in the body. So nowadays, you go to any doctor, any pediatrician, or even a general physician, they ask you to get your vitamin D3 profile done. And if they find, invariably they find it as lesser, so they're given supplements. Fine. Here, why I brought up this issue is, here they have mentioned something called 600 IU divided by 5 ml. So he talks about some international units, there is Indian pharmacopoeia, some 600 IUs divided by 5 ml. So you have a situation where you have some mass by some solvent. Suppose you dissolve, say, for an example, we could look at, okay, mass of solute. Supposing I dissolve 10 grams of, for example, 10 grams sodium chloride in 100 or 100 ml water into 100. So it becomes a 10% solution of NaCl. So we have a 10% solution of NaCl where 10 gram of NaCl were dissolved in, let us say, 100 ml of water. Suppose, and this, let us say, has a certain concentration. Oops. Again, we have lost connectivity. All right, we're, I suppose, again back on stream. This is the second disruption that we have had today. Obviously, there is some internet connectivity issue somewhere. We don't know where, whatever. Now here we take one example of, I just mentioned to you, 10 gram of NaCl dissolved in 100 ml water gives me a 10% solution of NaCl. What I will do is, I'll give you one example of, a textual example. Let us take this as a case. We have a question where we have 40 gram of common salt, NaCl, dissolved in 320 ml water. Now he wants us to calculate the percentage of solution. Now how do we do this? First of all, let us write out the data given to me. Mass of solute is equal to gram. Mass of solvent is equal to 320 gram. Instead of ml, he has given it as gram itself. Instead of ml, he has given me 320 gram of water. I'm sorry, by force of habit. Now we need to calculate the percentage of concentration of the solution. So what we do is total mass of solution is equal to 360 gram. Because mass of solute is there, mass of solvent is there, put them together, what you get is a solution that is 360 grams. So now we need to calculate the percentage concentration. So what we do is percentage concentration, percentage of solution, mass percentage. I'll write it as mass percentage of solution equal to mass of solute divided by mass of solution into 100. So that becomes how much? 40 divided by 360 into 100. So goes. So 360, you divide this, you get how much? 400 divided by 36. This is approximately equal to 11.11%. So we can say that the solution is about 11.1% concentrated. You can do the working and check the veracity of this statement. Now, we have talked about this word suspension some time back, and we did mention that suspensions are pretty opaque liquids. Light does not pass through them, and they are, when you allow a suspension to stand, the particles are so big that they settle down. Sometimes it so happens that yes, in fact it happens. You can, I just reminded of this because I was just trying to recall what best example I could give you. Making of paneer. Yeah, I suppose you know this. Paneer, is a dairy product. All right, take milk and heat the milk and add a dash of lemon juice to this. The water and the fat get separated and the fat becomes, so you can solidify that. And of course, it is used as a culinary agent while cooking, especially in the north of India. It is very very popular. Lots of paneer varieties are made, and of course they're used. We South Indians, we do not use it much, but of course now it's all become so homogeneous that everybody eats everything. All right, now I'm sorry, there was a unwanted call that came into my phone. I was forced to block that. Right. So I was talking about paneer. Paneer gives you that precipitation, the suspension. You can see the milk, in which the so-called colloid now becomes a precipitate. Now that leads me to what is called a colloidal solution. We mentioned about a colloidal solution some time back. I mentioned to you that a colloidal solution is one in which the particle size is between 1 and 100 nanometers. But what sense does it make to us? If you ask me, sir, what is so what? So what if the size is so big or so small? Does it make any sense to me? Yes, it does. Colloids play a very, very important role in our daily life activities. Right from the first activity that you perform, that is brushing your teeth, to probably the last activity that you perform, drinking milk before into bed, all these involve colloidal solutions. Right. So a colloidal solution, then of course, most important for us to live, talk to each other like this, view each other. We have blood circulating in the body, and that is a very important colloid. And you know what a beautiful system it does. It takes in oxygen and passes it on to the various organs, and then collects the carbon dioxide, and then exhale. We exhale. So blood is such a beautiful colloid that we should be grateful to the Almighty for having provided us with that. All right. Now, the colloids exhibit certain very important properties. One of the properties, which is very, very crucial to us, is called Tyndall effect. Tyndall effect, we have all seen Tyndall effect, but we have not probably recognized it. Tyndall effect, scattering of light by colloidal particles. Scattering of light by colloidal particles is called Tyndall effect. Now, where have we seen this in action? Well, we live in a country where we have a lot of dust. We're not Americans, we're not British, where most of the time it's either snowing or it is so rarefied that you don't have much dust. Here, of course, in our native country, let's be proud that we have a lot of dust. We do sweep, we clean everything, in spite of it, there's a dust. So when you wake up in the morning, if you have woken up at the time of sunrise, you can see the ray of the beam of light, sunlight passing through one of those small gaps in the window, in case you have or window curtains, drapes, whatever you have. If light is passing through, if you are lying down, you can see the path of the light beam, where you can see tiny, tiny particles floating about. Normal eye, you cannot detect these particles, but in the presence of that strong beam of light, you can see these particles actually floating in air. Or you say, no, sir, we haven't. I'm quite sure you have watched in your lifetime at least a few cinematic expositions. That is, you call them as movies. Right. These cinematic expositions, as you call them, when you go and sit in the theater, before the actual movie is screened, a lot of advertisements come on screen. And if you just look up, you can see a beautiful blue beam of light above your head. Again, those small, tiny, tiny particles. Now, these particles are visible because they are scattering that strong beam of light. Number 2. Number 3. If you are sitting as a front passenger in a car and somebody else is driving the car, you're driving in the night, you have your headlamp on, and in front of you there is a lorry which is going at certain speed and which is emitting a certain amount of smoke. In your headlight beam, you can see the path of your own beam, and the smoke is scattering that light. So these are some live examples of what is called Tyndall effect. So Tyndall effect is the scattering of light by colloidal particles. Normally, we observe these movements under an instrument called ultramicroscope. If you really want to take a very fine colloid, then normally you cannot see them with the naked eye, but using a ultra microscope, it was, as my memory serves right, Zsigmondy. Zsigmondy was the man who invented this ultra microscope. So through an ultra microscope, you can actually see the path of the light reflected by colloidal particles. So then we have a very important table coming up for us. This is a question that is quite likely to be there in the examination. We can have, we can make an attempt to prepare a small a table where different varieties of colloids are given to us. By the way, in a solution, you have a solute and a solvent. In the case of a colloid, the nomenclature is slightly different. You have a dispersed phase and a dispersion medium. A dispersed phase is what is dispersed in a bigger medium called the dispersion medium. Like the solute, you can equate a solute with a dispersed phase. The solvent, you can equate with a dispersion medium. Don't equate, but mentally you can keep that synonymity together. Now we make a small table here. Please, if you can always join me in writing this table. It will help you by a little more practice. We make a small table like this: dispersed phase, dispersion medium, then you have type, and you have example. Now this is a table which will run fairly long, so be prepared to draw a fairly long table. We have a liquid dispersed in a liquid. This is called, dispersed in a gas. We start with a gas, obviously here. It is called aerosol. Aerosol, example would be fog, mist, cloud. I don't know how many of you have walked into a cloud. It's a fantastic experience. If you go to Nandi Hills, for example, top of the Nandi Hills, if you go for a stroll early in the morning or late evening, you can actually walk through a cloud. It's a brilliant experience. I have personally had the experience. That kind of a ethereal, it's a very ethereal feeling that you get. All right, so we have a liquid and a gas. It's called aerosol. Aerosol, fog, cloud, mist, etc. You have a solid in a gas. This is again an aerosol. It's called a solid aerosol. The example that you very commonly come across: smoke and automobile exhaust. We mentioned about this. Even the smoke coming out of a burning piece of wood, or the exhaust gases of a car. Then you have a gas in a liquid. A gas and a gas cannot form a colloid because they're completely miscible. Remember, colloids are heterogeneous. So gas in a liquid is called a foam. The best example will be a shaving foam. And and a liquid in a liquid. A liquid in a liquid would be called emulsion. Well, I need not to tell you the examples for emulsion because you are constantly bombarded on the television by a number of paint companies which sell emulsions to paint your walls. But I would put my bet on milk. Milk is an example, a beautiful example for emulsion. Your face creams, those of you who use face creams, these are also examples of Yami Gautam, if I can relate to you that way. Yami Gautam endorses a product which is an emulsion. Then you have another few more coming up. You have a solid in a liquid, solid dispersed in a liquid. It is called a sol. Example of this would be milk of magnesia. Milk of magnesia. I'll slightly extend this here. You can relate to Saina Nehwal, if I think I'm right. She endorses a product called milk of magnesia. You can drink that and your stomach becomes more and more cleaner. That is what they say. Now, I talk about people who are commonly seen on television, and there is one cinema actress also who's very frequently seen on this milk of magnesia product. I don't remember her name, but anyway, you can probably know better. Then you have a gas in a solid. This is called a foam. This is foam rubber or sponge. Then you have a liquid in a solid. It's called a gel. You have jellies and butter. Then a solid in a solid. It's called a solid sol. And here you have gemstones. Gemstones. So all these aquamarines, the tourmalines, and whatever you have, all these are colored gemstones. Now, yeah, I guess we have about a couple of minutes more. One brief resumption of what we have done, a small resume of what we have done can be just seen now. We have today talked about solutions, we have talked about colloids, we have talked about suspensions, we have talked about different types of solutions, we have talked about concentrations of solutions. We've talked about, in fact, what is a colloidal solution. We've seen what is Tyndall effect. We have seen what are the types of colloids we have. Please remember this table. Please do copy this down from your text and display it prominently in your study place, because this is worth at least 2 marks for you in your examination. All right. So on this note, we break about a couple of minutes early. If there are any questions, queries, please put them up on the chat box. I'll wait for 2 more minutes. If you have put any questions, we shall answer them. If there are none, the parting statement is usually the same. Please do like us. Please post constructive comments which will help both of us to improve, me, all of us, to deliver better, and you to learn better. So thank you very much. If there are any queries, Navya, any questions, my dear?
No, sir, we didn't say any questions.
All right. So since there are no more questions coming up, I believe I'm closing about a couple of minutes. Maybe my watch is a little slow. There are 2 clocks I have in front of me. One is saying it is 15:59. The other says it is 15:57. So there's a
59, sir.
difference of 2 minutes between the two. It's all right. So if there are no more questions, no more queries, we break here. Thank you very much. Have a nice weekend. Bye-bye.
Thank you so much, sir.
Thank you, dear.
Thank you for your precious time.
Thank you, thank you, thank you.
Dear viewers, stay connected for many more sessions. Please like and share the video. Thank you.